Hello everyone, welcome to Memoneet. Welcome back again. I am Aprajita, your chemistry SME, and we are back with another session for the first chapter that we have been discussing, which is some basic concepts of chemistry. So let me tell you students, this is the last lecture on this topic. So we will be covering whatever topics are left for this chapter. All right, so let me just recall a little bit for you. So we have learned about the mole concept in the last session, and I hope that everybody has gone through that session and you people are clear with the mole concepts, right? So see, if in case you people are having any doubts, you can contact us. You can post your doubts in the comment section. We will definitely see it. We will definitely cater to it. Okay. So you need to tell us what problems you are facing while studying these topics. So we will try to help you out. Okay. So I hope that mole concept is pretty clear. So today we are going to learn about some other things like how to find out the empirical formula, the molecular formula, then about the stoichiometric calculations, and then a little bit about the calculations related to solutions, which is molarity, molality, mole fraction, and all of that. Okay. But do you remember one thing? I hope you remember. So while I was ending the last session, I told you to solve one question, right? I hope most of you, or like what I believe is like all of you have tried, at least tried that question, and you might have got the answer. All right. So I'm again telling, if you people get the answer, please post it in the comment section. Okay. So that I can see also that my students are doing good and they are actually solving the questions. Okay. And likewise, I promised you that I'll be discussing the solution as well as the answer in the next session. So before we start with our today's topic, I just want to give you the answer and the solution to the last question. Okay, the question that I have given you in the last session. So let us go through that. Alright students, so this was the question that I have asked you, that is, which one of the following will have largest number of atoms, that is 1 gram of gold, 1 gram of sodium, 1 gram of lithium and 1 gram of chlorine gas. Alright, so first of all, I have told you that whenever we have to calculate the number of atoms, okay, we need to find out the number of moles. For that, you must know the atomic masses. For here, we have the atoms that are given to us. So let us find out the number of moles for each of them. So what is the formula for number of moles? It is given mass upon the molar mass, right? Molar mass, so in this case, it would be the atomic mass for gold. So number of moles is 1 upon 197. 197 is the atomic mass for gold, alright. Then after that, for sodium, it would be 1 upon 23, with 23 is the atomic mass of sodium. For lithium, it's 1 upon 7, alright. And now for chlorine class, one thing to be noted here, don't mistake. So it's chlorine molecule, right? So for molecule, you have to take 35.5 plus 35.5. So you have to take the molecular mass. So it's 71. So 1 gram upon 71, it's the molar mass in this case. Now this is the number of moles. Now to calculate the number of atoms, you have to multiply all these values with the Avogadro's number. Okay, which is 6.022 into 10 to the power 23. Now are you going to do all these calculations in your NEET examination? So of course, if you have to find out the number of atoms, you need to do, right? But let me tell you one thing, that there's no requirement to do so. Now for chlorine, this is the number of molecules that we have got, right? Because I have taken the molecular mass. So this is the number of molecules. Now one molecule of chlorine has 2 atoms. So this much molecules will have. Now I will multiply this value by 2. Okay. So keep that in mind. This will be the number of atoms in the 1 gram of chlorine gas. Alright, so what we are going to do here is, now just see the values. See, this number is same now. We are dividing it with some numbers. You need to find out the largest number of atoms. So the denominator is smallest in this case. Here it's 7, 23, 197. Here also if you find out, it will be 35.5. So 7 is the smallest denominator. Means if you divide 6.022 into 10 to the power 23 with 7, you will get the maximum value in this case. Alright. So we have to find out the largest number of atoms. Of course, largest number of atoms will come in the third option. So the answer is 1 gram lithium. See, I saved all your calculation time in this case. So you have to keep these things in mind. Now don't just keep on calculating. It will take a lot of time, okay? In your exam, and time is very precious. Alright. So do such things. If they would have asked you the least number of atoms, then what would be the answer? They can ask that also, na, least number of atoms. The least number of atoms will be in this first case, because here the denominator is the biggest. So the value that you will be getting will be the least, no? So the answer for this particular question is option number 3. Now let us get back to our today's topic, what we are going to discuss today. Alright. Okay, so I am going to start with the topic, that is percentage composition. Alright class, so in the last session we have talked about how to calculate the number of entities that are present in a given sample, right? Number of atoms, molecules, using the mole concept. Now let me know if we are asked about the percentage. Like if we are asked about the percentage of any particular element which is present in a compound, that what we are going to do. So in that case, we will calculate the percentage composition. Now, what is percentage composition? Percentage composition tells us that how much percent of a particular element is present in a given compound. Let's say if I give you any unknown sample of any compound. So firstly, you want to know now what will be the constituents of that compound, and how much like particular element is present into that. So that percentage composition helps us to find out. Now, how I find the percentage composition of any particular element? So I have to take the mass of that particular element in the compound, okay? Like whatever compound you are having, take the mass of that particular element in the compound for which you are calculating the percentage composition, then divide it with the molar mass of compound. See, now I think there is no need to explain what is molar mass. You might have understood it from the last session, okay? Mass of 1 mole of that compound. And since we are calculating percentage, so multiply it with 100, okay? So now let's take an example, a very simple example I'm taking of water molecule. So if I need to find out the percentage of hydrogen present in the water molecule, then what I am going to do? See, when you learn the atomic masses, to take the whole values only. If you want to do it in decimal, you will get precise answers. But this much time we are not having in the exam, right? So because in that case you have to calculate using decimals. So just take the mass of hydrogen as 1 instead of 1.008. I would like to tell you, take it as 1. That would be easy. Answer would be same, no issues. Okay. So how many hydrogen atoms I have? 2. So mass of hydrogen in water is 2 into 1 divided by molar mass of water. You know it's 18. So 2 into 1 plus 16. No, it's 18. So 18 into 100. Okay. So it's 1 upon 9 into 100. So it will be coming out to be 11.11%. So means this much hydrogen is present in your water. Similarly, you can calculate the percentage of oxygen, which will be 16, because mass of oxygen is 16. You have only one atom in this case. So 16 upon 18 into 100. So it will be coming out to be 88.88%. Okay. So this is how we can calculate the percentage composition. All right. So now I'm giving you one question. Like I have a compound C2H5OH. Of course, it's ethanol. Okay. So try to find out the percentage of carbon, percentage of hydrogen, and percentage of oxygen in this particular compound. Okay. So you can find out the molar mass of carbon, which is like molar mass of this ethanol. So 2 into 12 plus 6 into 1 plus 16. So 24 plus 6. Alright, so you can do this. So it will be 46, okay, gram. So now you can similarly find out the percentage composition. Keep it noted in your notebook and please do it, alright. Now, how this percentage composition is helping us out? So this percentage composition helps us to find out the empirical formula of any compound. Now, what is empirical formula, class? So you know empirical formula, it actually tells us about the simplest ratio, or you can say simplest whole number ratio of various atoms which are present in the compound. Okay, so you know we have different kinds of atoms, different kinds of elements present in the compound. So if I take the simplest whole number ratio of those number of atoms of each type of element in the compound, I will get the empirical formula. Then what is molecular formula then? So we all know, students, कि molecular formula, it tells us the exact number of atoms. Okay, exact number and type of atoms of like each type present in your compound. Now the thing is that if we are given the percentage composition, how we are going to find out the number of of the empirical formula. Okay, so let me tell you that. Let's say I am having a question. Okay, this I have taken from your NCERT only. So in the particular compound, I have 4.07% of hydrogen, 24.27% of carbon and 71.65% of chlorine. And moreover, it is given that molar mass of this compound is 98.96 gram. I need to find out the empirical formula as well as the molecular formula of this compound. So what I am going to do is, firstly I will be writing whichever elements are there, hydrogen, carbon and chlorine. Since it's in percentage, I'll be converting it to grams. So let's say if I'm having 100 gram of the compound, so 4.07 grams would be hydrogen, 24.27 grams would be your carbon and chlorine would be 71.65. See, this is the reason I have given you the mole concept before this session, because here now I want to calculate the number of moles of each element. Now how I am going to calculate the number of moles? By dividing it with their molar masses. So in this case, molar masses will be the atomic masses. So since it's in decimal, I am taking 1.008. No worry students, you can take 1 also. Okay. So in that case, the simplest ratio will come in decimal. You can round it off. No issues. Alright. So then it's coming out to be 4.04. You can do the calculations. I have already done it to save time. So 12.01. 2.021 it will come, and for chlorine 71.65. So you know atomic mass is 35.5, no, so 35.45 to be exact. So it's 2.021. Now this is the number of moles you have got for each element, no, this. Now what you have to do is find the minimum value, smallest value. Now out of these, the smallest value is 2.021. Now what I have to do in the next step, I need to find out the simplest ratio. Okay. How we will find out the simplest ratio? By dividing these values with the smallest value. So it will come out to be 2. I am taking the rounded off. If it comes in decimal, no issues. Just round it off to the nearest whole number. Okay. Then I'll be dividing this value by the smallest value, which is 2.021 itself, and the last one as well. So this ratio I have got, this gives me the simplest ratio of these elements. So how much carbon I have? 1, right? So I'll write the empirical formula as C. Then I will be writing H2, since for hydrogen the coefficient is 2, and it's Cl. So CH2Cl is the empirical formula. Now one more thing was given, the molar mass was given, and using this molar mass, which is 98.96 grams, I need to find out the this thing, your molecular formula. So I'll find out the value of N. So what is N? N is the molar mass upon the empirical formula mass. Empirical formula mass I will calculate from the empirical formula that I have got. Alright. So students, now can you calculate the empirical formula mass? So it is 1 carbon atom, so 12.01 plus 2 hydrogens, 2 into 1.008, and 1 chlorine, 35.45 to be exact. Again, I have taken decimal values. Don't worry if you don't want to take. That's not an issue. So it will come out to be 49.48 grams. Now I can find out the value of N easily. So 98.96 divided by 49.48. So it's coming out to be exactly 2. So this N is equal to 2. Now I will multiply this empirical formula with 2. So to get the molecular formula. So C2H4Cl2, this is the molecular formula of this compound. Okay. So students, I hope you have understood all the steps to find out the empirical and the molecular formula. Let me tell you one thing. Recently, like Neet 2024 May, this question was asked about empirical formula. They have given you the percentages and we have to find out the empirical formula, right? So see, 4 marks you are getting from here only by just learning how to find out the empirical formula. So that is why this makes it an important topic. Now I'll be starting by talking about the stoichiometry and its calculations. So stoichiometry is nothing, students. It's very simple. Of course, the word looks like very heavy and very difficult. Though, but it is very easy. It is something that deals with the calculations of masses. Okay, deals with the calculations of masses, or I can say volume sometimes as well. If we are talking about gases, of course, of the reactants and products. Now you will say what ma'am is saying, we are not getting anything, no? So actually, when some reaction is proceeding, how much reactant would be required to get that product? Or if we are taking this much reactant, how much product I will get? Right, that's also something very important now in industrial manufacturing. Also, if I want to say manufacture ammonia, I must know ki how much nitrogen and hydrogen in what ratio and everything that is required, na, that we must know. So that we get to know from the stoichiometry only. All right, so that's why it's important. And again, let me tell you, you will get questions from this topic as well. In your Brahmastra part test also, we have got some questions from this topic. And of course, in your NEET exam, we have this topic, all right. So let's say I'm having an equation. The very first thing is, when you are talking about stoichiometry, the equation must be a balanced chemical equation. Okay. Because if the equation is not balanced, we will not know about the reaction, everything. We will not able to do it, okay, properly. So let's say I'm writing an equation for the combustion of methane gas, CH4 plus 2O2. So let me tell you what what information you are getting from this equation, right? So first of all, in brackets we have written gas, so it means all of them are in gaseous state. Similarly, we write S for solid, L for liquid, then we can write aqueous also. Now, these coefficients, like this 2 is here, no? Let me highlight it. This 2 is here, this 2 is here. These are known as stoichiometric coefficients. Alright. This actually tells you about how many molecules or how many moles of the reactant are reacting. So if I talk about this particular reaction, I am saying that 1 mole of methane reacts with 2 moles of oxygen gas to form 2 moles of carbon dioxide, sorry, 1 mole of carbon dioxide, okay, since the coefficient is 1, and 2 moles of water. Similarly, I can say molecule also. 1 molecule of methane is reacting with 2 molecules of oxygen to form 1 molecule of CO2 and 2 molecules of water. Next up is, if you know, I have given you in the last session, 1 mole of any gas at STP will have 22.7 liters of volume. Okay, like at 1 bar pressure, remember. So 22.7 liters of methane will react with 2 into 22.7, means 45.4 liters of oxygen to form 22.7 liters of carbon dioxide, and again 45.4 liters of water vapors. Now you know the mass of 1 mole of substance is the molar mass. So in that way I can say 16 grams of methane will react with 2 into 32, means 64 grams of oxygen to form 44 grams of CO2, and to form 2 into 18 means 36 grams of water. So all these information we are going to get from the balanced chemical equation, and we can use these things to do our stoichiometric calculations. Okay, so once you will go through the numerical problems related to this question, related to this topic, you can easily understand whatever it is. Okay. Okay, so let me give you one question so that you can understand this like concept clearly. So the question is that how many moles of methane are required to produce 22 grams of CO2 after combustion? Okay, everything is written in front of you. If you have understood it really well, you can do this question like 2 minutes. Okay, 2 minutes also is very excess I have given you, but still we can do it. So I need to find out how many moles of methane are required to produce 22 grams of CO2. Now from the stoichiometric coefficients, you can see 1 mole methane gives 1 mole of CO2. So 1 mole methane is 16 grams, which is giving you 44 grams of CO2. So it means that 44 grams of CO2 is produced by combustion of 1 mole of methane. Okay. Simple. Now in the question, how much they have asked? 22 grams. Means if I need to have 22 grams of CO2, I need to do the combustion of how much methane? So 1 upon 44 into 22, this unitary method that you have studied in mathematics. So it will be 1 upon 2, which is 0.5. So you will be getting you will be requiring 0.45 moles of methane to produce 22 grams of CO2. Right? So this is very easy, like something that a very basic concept it is. So you can solve any type of questions using these stoichiometric calculations. Okay. Now students, one more term comes in the reactions, that is limiting reagent. You might have heard of it. I would like to tell you because some questions have been asked from this topic as well. So you know that, see, this is the balanced equation, and according to this I require 16 grams methane and 64 grams oxygen to react according to the balanced equation. But it's not necessary I am having these exact amounts. Sometimes I can have different amounts than what is required by a balanced equation, right? Means one reactant can be in more amount, the other reactant could be in less amount. So in that case we have limiting reagent. Now let's say if I am having that a reactant that is present in less amount. Okay, so if that reactant is present in less amount, means it will get consumed first. Okay, and if it gets consumed first, what will happen? The reaction will stop because I am not having second reactant only. So the reaction will stop, means the product will be limited, right? So this reactant that is present in less amount, which get consumed first in the reaction, and it limits the formation of product, that we call as limiting reagent. Okay, so that is the meaning of limiting reagent. Let's say for this reaction only, you know, 16 grams of methane requires 64 grams of oxygen for combustion. Okay. So let's say I am having only 32 grams of oxygen in the reaction. So what does that mean? If I am having 32 grams of oxygen in the reaction, will combustion of all of the methane happens? No, right? The combustion of all of methane will not happen. The reaction will stop when this 32 grams of oxygen is utilized. So in this particular case, your oxygen will be the limiting reagent because it is not letting the reaction to complete because the amount of oxygen is less. Okay. So that is the concept of limiting reagent. So students, whenever so in this particular chapter we are mainly talking about the calculation parts. Okay, so there is this chapter called solutions. In that case also we have a lot of calculation work, like lot of things are there. So you know that we require some quantities to represent the concentrations of the solution, like how much amount of solute is present, and in terms of moles also. Everything you might have learned it in lower classes, but now we'll be talking about in the terms of moles. So in that case, we have certain terms that are required to represent the concentration of the solutions. We will have a brief discussion on that because in detail we will learn them when we will be studying the chapter solutions. Okay. Okay, so the very first term is mass percent. Okay, mass percentage. So class, it's very simple. Just like we have calculated the percentage composition, here we are talking about mass percentage. So actually we are representing concentration. So everything will be done with respect to the solution. So mass percentage formula will be mass of solute. And in the denominator, what will you take? Will you take the mass of solvent or solution? Exactly, we will be taking the mass of solution, okay, and multiplied by 100. Okay, for example, let's say I am having 2 grams of substance A, which is dissolved in 18 grams of water. Can you calculate the mass percentage? Do it quickly, just it will take hardly 1 minute, okay. So what will be here? It's the solute. The mass of solute is 2 grams. So I'll take 2 in the numerator. Mass of solution. Now mass of solution means mass of solute plus mass of solvent. So what is the solvent here? 2 plus 18 into 100. So 2 upon 20 into 100. Right? So this is going to be the answer. And you will be getting 10%. So means the mass percentage of this particular solution is 10%. Okay. Now you have studied about the number of moles, right? Now there is term known as mole fraction that we use. Now what is mole fraction? So let's say if I am having two components A and B in the solution, A is the solute, B is the solvent, let's say. And the number of moles of A is Na and number of moles of B is Nb. So mole fraction of A would be the number of moles of A divided by the total number of moles. Okay. So whatever component you are taking, divide the total number of moles, you will get the mole fraction. You will denote it by XA. Similarly for B, the mole fraction would be number of moles of component B divided by the total number of moles. Okay. So this is something which we call as mole fraction. Very simple, very easy. So all these are the basic things, right? These we'll be using when we'll be studying the topics later on. Okay. So now the next thing is your molarity and molality, something very important. So molarity is denoted by capital M. It's the most used thing which we are using for these solutions. So molarity means the number of moles of solute present in 1 liter of solution. Okay. So here the volume, or you can say it's present per liter of solution. Keep 1 liter of solution mein how many number of moles you are having, that is the molarity. Let's say I am having 1 molar NaOH. So 1 molar NaOH means that 1 mole of NaOH is present in 1 liter of the solution. Okay, means the volume of the complete solution is 1 liter. Now you know where these things are used when you are preparing your solutions for lab. Let's say this standard solution is there, 1 molar NaOH. Now in your experiment, you don't require 1 molar NaOH, you require 0.2 molar NaOH. So you have to use this 1 molar NaOH to prepare 0.2 molar NaOH. Yes, this can happen. We can prepare this. So 1 molar NaOH means 1 mole of NaOH is in 1 liter and 0.2 mole is in 1 liter. So I need that much volume where 0.2 mole is present. I need that much volume of this NaOH in which 0.2 is present, and then I'll dilute it. So what I am going to do in this case, let us see. So there is an equation known as molarity equation, which is M1V1 equals M2V2, where M1, M2 are the molarities, M2, V2 are the volume. So we'll be using these formulas to find out the concentrations or the volumes, whatever have been asked. Now I am having this 1 liter of 1 molar NaOH. Okay. How much volume? So how much volume should I take of this 1 liter solution so that I can get 0.2 molar NaOH? Okay, so M1 is 0.2. I want to prepare 0.2 molar NaOH, and how much volume I want to prepare? 1 liter. Okay, so I'll be taking, like, you can take 1000 ml. Okay, all right. Then M2 is the molarity of the standard solution that we have taken, which is 1 mole. Okay, so 1 molar into how much volume I require, that I will get from here. So from V2 it will be 0.2 into 1000. So it will be coming out to be 1200 ml. See, that's very simple. So I'll be taking 200 ml of this 1 molar NaOH and diluting it with water to make the volume 1000 ml. The resultant solution will have 0.2 moles of NaOH in 1 liter, means 0.2 molar NaOH. So this is how molarity equations will be used. Okay. Now if I talk about the molality. Now what is this molality? It is the number of moles of solute which is present in 1 kg of the solvent. Okay, here we will be talking about solvent, not solution. So it is present in 1 kg of solvent. So what is the formula of molality? It will be denoted by small m. Okay, capital M is molarity and small m is molality. The number of moles of solute and divided with the mass of solvent in kilograms. Okay, so once you divide it with the mass of solvent with kilograms, you will get the molality. Okay, and these are the terms that we are actually using for representing the concentration of various type of solutions. In detail we will be learning it in your solution chapter. Okay, so students, with that we have covered all the topics of this Brahmastra part test 1. That chapter was some basic concepts of chemistry. Alright, so I have tried to cover all the important topics. I have again told you that we are covering those topics which are important from Neet point of view. Okay, so we are covering previous year topics, like from the topics most number of questions are asked, I have covered all of them. So now what I want you to do is, you have watched the video lectures, go through our PYQ book, okay, practice all the PYQs of this chapter. So you know that you will be getting the chapter wise PYQs, so no need to like find them anywhere else. So you practice all those questions, okay. Then go through the line by line in NCERT, whatever notes are given to you on our application. Go through that and definitely you will be prepared for your BPT 1. And I hope all of you are going to do well in that exam. Alright. So again, I would like to tell, if there is any doubt, please post in the comments. So we will try to cater to all your doubts. Alright students. So see you soon in our next lecture video. So until then, all the very best for your Brahmastra part test 1. Okay, do well. So all of you must score good marks in that. Alright. So study hard and we will meet in the next session. Until then, take care. Thank you. Bye bye everyone.